Timeless Concepts from Physics Helpline. This is a video tutorial series through which we will sharpen our problem-solving skill. First, we will analyze the problem on hand to find the related concepts. Then, using these, we will develop a method which will produce the solution. This will help the students aspiring to get into IIT to understand the much needed advanced theories and applications in physics. In this video tutorial, we will discuss 3 more multiple choice questions in kinematics with a shortcut method for one of the problems. The questions are as follows. A body dropped from the top of a tall tower covers a distance 7x in the last second of its journey, where x is the distance covered by it in the first second. Then the time taken by it to reach the ground is, take acceleration due to gravity is equal to 10 meters per second square. The options are 3 seconds, 4 seconds, 5 seconds and 6 seconds. Question 2. A body is projected horizontally from the top of a tall tower with speed 10 meters per second. Then the magnitude of its displacement in the first 2 seconds is, take acceleration due to gravity is equal to 10 meters per second square. The options are 10 into root 2 meters, 20 into root 2 meters, 30 into root 2 meters and 40 into root 2 meters. Question 3. A body thrown upwards with speed 100 meters per second covers a distance of x meters in the last second of its upward journey. If the same body is thrown upwards with speed 200 meters per second, the distance covered by it in the last second of its upward journey is y meters. Then the ratio x by y is, take acceleration due to gravity is equal to 10 meters per second square. The options are 0.25, 0.5, 1 and 2. First, let us solve the problem in question 1. The situation is shown in the figure. For a body moving with uniform acceleration a, whose initial velocity is equal to u, the distance covered by it in the first n seconds is given by Sn is equal to un plus half an square, and the distance covered in the nth second is Snth is equal to u plus a by 2 into 2n minus 1. When a body is dropped from a given height, its initial velocity is equal to 0 and acceleration is equal to g. Therefore, we have Sn is equal to half gn square and Snth is equal to g by 2 into 2n minus 1. In the question, it is given that the distance covered in the nth second is equal to 7x and the distance covered in the first second is equal to x. Therefore, Snth is equal to g by 2 into 2n minus 1, which is equal to 5 into 2n minus 1, which is equal to 10n minus 5. Therefore, we have 7x is equal to 10n minus 5 and S first is equal to g by 2 into 2 into 1, minus 1, which is equal to 5. Therefore, we have x is equal to 5, which implies 7x is equal to 35. From equations 5 and 6, we get 10n minus 5 is equal to 35, or n is equal to 4 seconds. Therefore, the correct option is B, which is the answer to question 1. Now, we will solve the problem in question 2. The situation is shown in the figure. When a body is projected horizontally from the top of a tower, its motion is two-dimensional. Its horizontal motion is uniform, as acceleration due to gravity acts perpendicular to its motion, and its vertically downward motion is non-uniform. It starts from rest and comes under the influence of acceleration due to gravity. We will take x-axis and y-axis along the horizontal and vertical directions respectively. Therefore, horizontal displacement in t seconds is given by x is equal to vx into t, and vertical displacement in t seconds is given by y is equal to half gt square, since initial velocity in the downward direction is 0. It is given that Vx is equal to 10 meters per second, t is equal to 2 seconds. Therefore, we have x is equal to Vx into t, which is equal to 20 meters. Since it is positive, we write x is equal to 20 meters into I cap. Similarly, in the vertical direction, we have y is equal to half gt square, which is equal to half into 10 into 4, which is equal to 20 meters. Since it is negative, we write y is equal to minus 20 meters into j cap. Therefore, displacement of the body in 2 seconds is s is equal to x plus y, which is equal to 20 meters into I cap minus 20 meters into j cap. Therefore, magnitude of displacement is equal to 20 into root 2 meters. Therefore, the correct option is B, which is the answer to question 2. Finally, we will solve the problem in question 3. The situation is shown in the figure. For a body projected upwards with initial velocity u, it stops at the highest point, therefore v is equal to 0. Acceleration due to gravity is equal to minus g, as it is acting in the downward direction. If the time taken for the upward journey is equal to t seconds, then we have v is equal to u minus gt, and distance covered in the nth second is s nth is equal to u minus g by 2 into 2n minus 1. In the first case, u is equal to 100 meters per second, v is equal to 0, and g is equal to 10 meters per second square. Putting the values in equation 1, we get 0 is equal to 100 minus 10t, which implies t is equal to 10 seconds. Therefore, distance covered in the 10th second is equal to 100 minus 10 by 2 into 20 minus 1, which is equal to 5 meters. Therefore, we have x is equal to 5 meters. Similarly, in the second case, u is equal to 200 meters per second, v is equal to 0, and g is equal to 10 meters per second square. Therefore, we have 0 is equal to 200 minus 10t, which implies t is equal to 20 seconds. Therefore, distance covered in the 20th second is 200 minus 10 by 2 into 40 minus 1, which is equal to 5 meters. Therefore, we have y is equal to 5 meters. Therefore, the required ratio x by y is equal to 1. Therefore, the correct option is C, which is the answer to question 3. Now, we will discuss a shortcut method for question 3. Consider the equation V is equal to U minus GT. Therefore, when V is equal to 0, we have T is equal to U by G. When time of journey is equal to n seconds, we have n is equal to U by G. Therefore, distance covered in the nth second is equal to U minus G by 2 into 2 into U by G minus 1, which is equal to U minus U plus G by 2, which is equal to G by 2. Therefore, the result is independent of the speed of projection, which implies that x is equal to y is equal to G by 2. Therefore, the required ratio is equal to 1. Therefore, the correct option is C, which is the answer to question 3. This completes the answers to the questions.